Alright, so Unit 3, Day 2, we're looking at transformations and a bunch of rules that we're going to learn that shows how functions change. Okay? After we learn all these rules, I'm going to try to condense them to 3 major rules with one little caveat, one little warning, okay? And it should work for every single function. It doesn't matter whether it's absolute and all the other ones that you're learning this year, because you're learning a lot of functions this year, okay? Alright, so the a value is a vertical stretch when a is bigger than 1. That means you are stretching vertically, and a is a number that's in front of x. So my equation that I'm going to be talking about today looks like the following for the absolute value. Y is equal to a absolute value. You have like a b in here with an x minus c plus d. I know it's a lot, but I will make it easy for you, okay? So a is multiplying this whole absolute value piece. B is multiplying inside. C is either subtracting or adding. And D is either subtracting or adding. Okay? So what you did with your groups, or the partner that you got assigned to just moments ago, addition and subtraction do something, and multiplication and division do something different. Okay? So, vertical stretch. That could be something like a is bigger than 2. So an example could be, bigger than 1. An example could be 2 times the absolute value of x. Okay, go with me? So let's look at the original one. So the original one I'm going to do in black. If I go up 1 over 1, up 1 to the left 1, it almost looks like it has a slope of negative 1 or 2. Sorry, negative 1 or positive 1. And what we're going to do is we're now going to vertically stretch this by 2. Okay? So that means it's going to stretch vertically. So here's a good kind of visual for you. This graph, if I stretched it, will do this. You with me? What did it look like? What did it look like it did? It looked like it was closing up, right? It was steeper. Okay? If I don't stretch it, let's say that I compress it, it would do this. I'm vertically changing it right now. These are all vertical changes. And it all falls in either vertical, which is y, which is up and down, or horizontal, which is x, which is left or right. Those are the 2 main categories that all of this information today falls under. Okay? So a vertical compression looks like I just squished it. Like I'm this huge giant, right? Whatever. And I just squished the graph vertically. So I squished it down. Stretching it is like if I were to pull this apart. So if I'm stretching it, it's like I'm pulling this apart and making it steeper. Okay? And then the other ones are just simply shifts, which are translations, which are just slides. Okay? So if I looked at, again, the absolute value function, a shift could be this. Shift to the left, shift to the right, or shift up or down. Are we good? And last but not least, reflections. Reflections are like when you look in the mirror and you see your reflection. You need that mirror there. And let's say that I was reflecting this across this line here. So a reflection would look something like the following. Let's see if it'll let me do it. Yeah. So a reflection would just basically reflect across but end up down here. You with me? And you can do that horizontally as well. Those are the big things that we're looking at today. Okay? Alright, so let's go back to our notes. So this is going to stretch vertically to where the rise over run is no longer by 1. It's now by 2. Okay? So I can look at this almost like a slope. It's not y equals mx plus b, but I can look at it like that. So I will go up 2 over 1, up 2 over 1, up 2 over 1, so on and so forth. And I'll go up to the left 1, up 2 to the left 1, so on and so forth. And in red, you just saw the graph of 2x, or 2 times the absolute value of x. Yeah?
So that would mean like it would be vertical stretch by a factor of 2.
Perfect.
Okay.
That's exactly how it's going to be worded. Vertical stretch by a factor of 2. Now, A is between 0 and 1. A lot of people think that since this was greater than 1, as long as this is less than 1, it's going to be a compression. But it's not. What if it was negative 8? That's not a compression. It has to be between 0 and 1. So visually, when I was your age, I actually had to write out 0 and 1, and it's basically going to be a fraction that exists in between those, but not 1 and not 0. Because if it was 0, what would happen? It just zero out. What if it was 1? Nothing would happen. It would just stay the same. If I multiplied your height right now by 1, nothing happens. But if I multiply your height by 2, you just vertically stretched. You with me? So A is bigger than 1. Okay? If it stretches. If it's between 0 and 1, it will be a compression. And an example of this looks like that. A fraction that's between 0, aka positive 0, and positive 1. Okay? And I know there's no positive or negative 0. I'm just trying to show and explain to you that it's right here between 0 and 1. So a vertical reflection is if A is what? The way I want you to read this going forward, instead of saying it like an inequality, A is less than 0, I would rather you say A is negative. Okay? So if you're less than 0, now for this unit, I want you thinking the word negative. If you're greater than 0, I want you thinking positive. So if A is negative, the graph would look something like negative absolute value of x. Okay? So let's go ahead and graph what these look like. So the original one that has a slope of up 1 over 1, up 1 over 1, that's the reflection. And then the other one, which was blue, is going to have a slope, right? A slope of 1/2. So up 1 over 2, up 1 over 2, up 1 over 2. Up 1 to the left 2, up 1 to the left 2, up 1 to the left 2. And you can see, like that giant analogy that I showed, that if you compress it, it makes it wider. If you stretch it, it makes it narrower. And if you multiply it by a negative, you just turn it and reflect it.
So for the vertical compression, we write it like vertical compression by a factor of 1/2.
Perfect, just like that. Yeah. All right. Let's go ahead and do that right now because I think you guys are with him as well as far as going to that level already, and that's fast. So I want you to write right here in words. I want you to write this is a vertical stretch by a factor of 2. This one, I want you to write a vertical compression by a factor of 1/2. And guys, compression to me, so vertical stretch and compression, right? I kind of think almost like this is just me being visual. So let's pretend that I drew an awesome accordion. So an accordion, when I'm stretching it, you're just pulling that accordion out, right? And when you're compressing it, you're just squeezing that accordion in. You with me? All right, so there's thinking of compressions versus stretches. Cool. Or slinky as well. Yeah, slinky as well. So let's say that you had a weight at the end and a a vertical stretch would be this. A vertical compression would be that. Actually, the way that I drew that, I don't like that. Let me fix that. Sorry, I'm just now being weird. But anyway, so let's say that this is here. This is my block of where it's going to be located. And a vertical stretch will look like this. Right? And a horizontal one would be the same. Y'all with me? Compression stretches. I just want to make sure that it's locked in immediately. Alright, and then this one is some people say that you don't need it. I say just write it just so that you don't make a mistake of saying the wrong axis. Vertical reflects, or vertical reflection across what? The x-axis. Which makes sense, because if you're vertically reflecting y-wise, you're going across x. And if you're horizontally reflecting, you're going across y.
Is it possible to perform a reflection and a stretch or compression at the same time? So if it was reflected by a factor of -3.
So here's what I'm going to say. The -3 part, instead of, you see what he just said? He goes, what if you had like a -3? I would want you to look at that as two things rather than one. You with me? Because -3, does it belong between 0 and 1? No. It is less than 1, but it is not between 0 and 1. So I don't want you thinking about it just as one thing. I want you thinking of the negative as a reflection and the 3 as a stretch. You with me? Okay. Alright. So let's move on to our next example. The B value is different. Okay? So the way I want you to kind of think about this, so far we followed intuition and we followed the rule. This is like me leading you to the shortcut that I'm trying to give you at the very end of the notes. And over here, the B value, I said this last class, is with the x. Okay? And just the x. Think of it however you want. Ex-boyfriend, ex-girlfriend, ex-husband, ex-wife, whatever. Okay? You are doing, or you're interpreting the opposite. And to me it's a good reason to know, yeah, if I'm with X, I'm doing the opposite. That's why that X is my X, because I was doing the opposite of what that person wanted. But if I'm not with the X, I follow the rule. Always. Okay? So now, here we go. B is this value right here. And if B is 1, immediately, what's the very first word that you think I want you to describe the transformation? The very first word. Horizontal. So all of these over here with the y value outside of the x, they were all vertical. Okay? And that goes back to what I was showing you at the very beginning. Vertical versus horizontal. Vertical meaning up and down. Horizontal meaning left and right. Okay? So this is going to be a horizontal. Guys, if B is bigger than 1, we learned just moments ago that if I'm bigger than 1, what does it look like it wants to do? It looks like it wants to stretch. You with me? But because it's with the x, it's not going to be a stretch. It's going to be a what? A compression. You with me? So you're going to show something like, let's say that I wrote y is equal to 2x on the inside. The first word you're going to write is a horizontal. That 2 looks like it's stretching, but we're with the x, so we're going to do the opposite. So it's a compression, not by 2. Who said that? Nice, by 1/2. Reciprocate that. So whatever that fraction is, do the reciprocal. Flip it. So compression by a factor of 1/2. Okay? Does that make sense? Okay. So now let's go over here and say, what if b was smaller than 1 but bigger than 0? So what if I had an equation that looked like 1/2 x like this? What's the first word that I write down? Horizontal. Because it's with the what? It's with the x. So it's a horizontal. At first glance, that 1/2 looks like it's going to be a what? Compression. But we're with the x. So you're going to do the opposite. So it's a horizontal what? Stretch by 2. And you could say 2 over 1. Horizontal stretch by 2. By, whoops, a factor of 2. Okay? And then the horizontal reflection, when b is less than 0, so in other words, if you had, or b is negative, you would have something that looks like this. And what does that reflect across? The y-axis. Because it's a horizontal reflection. And do that with your hand if you need to. You're reflecting across the y-axis. Okay? So we'll say horizontal reflection across the y-axis. Okay? So let's do, in green, this last one. So if I reflect across the y-axis, how does the original one change? It doesn't, right? It doesn't. What used to be here is now going to be over here. And what used to be originally over here is going to now be over here. So nothing changed. I mean, it reflected, but the graph still looks the same. Okay, so now let's look at the horizontal compression by a factor of 1/2. Okay? So what's going to happen?
So the slope is going to increase, basically. Whenever you're graphing, the slope's going to increase.
So if I do a horizontal compression, that's what this is, right? We said it's a horizontal compression. I want you to think of the graphs that we did. Okay, you ready? Here we go. This is a vertical stretch. Do you see what's going on? Alright, so let me show this two different ways. A vertical stretch, we'll do that. A horizontal compression, we'll do this. Do they look the same? They do. They do. You see what I'm saying? So whenever I go back, it will look very similar to what the other one could be, but it's a different way of looking at it. Okay? So let's go ahead and graph this. At 0, it would be 0. At 1, it would be what? 2. At 2, it would be 4. Y'all with me, guys? And then it's just going to have a slope. Still, it looks like it still has a slope of 2. But it wasn't a stretch. It was a horizontal compression. Y'all with me? Alright, so this would also be the same. Now let's go to this last one. This one is a horizontal stretch by a factor of 2. So at 0, what is it? 0. At 1, it's 1/2, and I'm not going to graph that. But at 2, when x is 2, what will my answer be? 1. When x is 4, what will my answer be? 2. So it makes it wider. So a horizontal stretch looks the same as a vertical compression. And a horizontal compression looks the same as if it was a vertical stretch. Okay. Good stuff. Any questions before I keep going? Okay. So that's A and B, the multiplication stuff. To me, I think that's the most difficult. and then the addition is pretty cake. Alright, so let's go to C. Again, our equation is this. Okay? So C is a phase shift, otherwise a translation. And not English to Spanish translation, but a translation is like we were saying yesterday. Slide to the left, slide to the right, slide up, or slide down. Alright, so translate to the right when C is positive. Okay? So if C is positive, I know this looks confusing. But right now, because of my original default function, C is a positive 2. Because if C was negative and I put this like a negative 2, what would this negative make this into? A positive. You with me? So the easiest way I teach students is that whatever you see with the X, we're going to interpret the opposite. So when I see X minus 2, it almost looks like I should move 2 to the left. You with me? But since I'm with the X, I'm not moving 2 to the left. I'm moving 2 to the right because I'm doing the opposite. You with me? All right. So this is going to be a horizontal shift or translation if you want, 2 to the right. And let's say C was negative. And again, I know this looks confusing, but you could have an example that looks like X plus 2. Technically, right now, C is negative. Do y'all know what the number is? Negative 2. Because from my equation up here, it's X minus a negative 2. So if C is negative, which is a negative 2, and I'm using this equation, a negative times a negative would become a positive. But again, I teach students this. If you're with the X, just do the opposite. Instead of moving 2 to the right, you're going to shift 2 to the left. So let's go ahead and write that in. So we'll say a horizontal shift or translation 2 units to the left. Okay, so let's go ahead and graph this one that we're moving left in red. Does it stretch or compress? No, everything stays the same. So it'll look something like this. Okay? And then 2 to the right would look something like that. Those are easy, right? It should be easy. Alright, so the last ones. If D is positive, let's say that it was like y equals x, or sorry, absolute value of x plus 4. Which way is it going to shift? Up. It's going to shift up. It's a vertical shift 4 units up. Oh, not just 2, 4. 2, 1, 2, 3, 4. Can someone tell me why didn't I do the opposite? Because I'm not with the X. If I'm not with the X, I follow the rule. Okay? And then the last one is, what if D was negative? So it would go down. So you could say something like, what if it was absolute value of x minus 3? 1, 2, 3. There would be my graph. And it's just a shift. Cool? Questions? Because it is a lot, but if you just use the 3 little rules that I'll get to here in just a bit, it's easy to find those transformations fast. Bless you. So are there any questions right now that you have for me? Okay. So now, let's look at your homework a little bit. what was the question that you were a little unsure as far as how to express it as a transformation? Any of them? Because you had like 1 through 10, right? 9? Okay. So number 9 from your homework, did it say g of x was like negative f of x?
Yes.
Okay. So the original f of x was this. That's like the parent function. Okay? So the parent function, like your parent, your mom, or your dad, they're the original ones. You are a transformation, if you will, from them. You have a lot of same features. You might have the same hair, the same eyes, the same smile, but some of you is different, obviously, from your parent. Go with me? So when I'm looking at this, right now, this is the parent function. So if I built it, it would literally be the negative of this. So the negative of the parent. So think about this being, let's say your mom, like the parent function, like the mother function, and then over here, this is you. Okay, you're the alteration, you're the transformation of the parent. Okay? Alright. So you tell me, this is the only thing that's different right now. And it could be your eyes, the color of your eyes. Is it vertical or horizontal? It's vertical. So here are your rules. It's either vertical or it's horizontal. Rule 2 is, what is the transformation? So we'll say transformation and then 3, if it's x, otherwise the x, we do what? The opposite. And the last rule that you need to know is that coefficient of x must be positive 1. So the coefficient of x must be, positive 1. Before you do all the interpretations. So it's like this has to happen first. Okay? Alright, here we go. And I'll walk you through this with color highlight. Is the coefficient of x positive 1 right now? Yep, so we're ready to rock and roll. The first thing, is it vertical? So, is this vertical or is it horizontal? It's vertical because what? It's not with the x. What is a negative transformation? What does it do? It reflects. So this is going to be, and I'm going to write it as we go through it, this will be a vertical reflection across what? I was going a little bit too fast, but across the x-axis. Do I even use rule 3? No, because I never had it with the x, right? So my only transformation was that. That means, again, the parent function, where I originally started, your parent, which started right here as this, when you vertically reflect it, g of x, this is you, is down here. Make sense? Easy enough, right? Alright. I'll do one more and then I'm going to give you some difficult ones talk through with me, okay? What's another one from the homework that you wanted to look at transformation-wise? Number 7? What does it say?
It's a f of 3 of x.
F of 3 of x. Okay, so this is your transformation. The parent, your mom, she started as that. Okay? So the parent function, we know what that normally looks like by default, right? By default. And now, here we go. Let's go through our steps. Horizontal or vertical? Horizontal, because it's with the x. I'm multiplying by 3. So what kind of transformation could it be? Because it's multiplication. It could be a compression or a stretch because it's multiplication. Okay? So I'm thinking, at first glance, what does it look like at first glance? A stretch. It looks like a stretch because it's bigger than what? 1. It's like tripling the height. Okay? So it looks like a horizontal stretch by 3, but we're going to say it's with the x. So we're going to do the opposite. So we're going to say what?
Horizontal compression.
Compression by a factor of 1/3. You have to take the reciprocal. Cool? So if I horizontally compress this, will it make it steeper or will it make it wider? If I horizontally compress it, will it make it steeper or wider? Steeper. And my slope, okay, so right here, this is u. At 0, it would be 0. At 1, it would be 1/3. You with me? But at 3, it would be what? 1. So did I just do, oh, I'm sorry. No one said anything. This shouldn't have been a 1/3. It should have been a 3. Right? So at 0, it's still 0. But at 1, it's what? 3. At 1, instead of being 1, like the original parent was, it's now way up here at 3. Please ask me questions before I give you the multiple transformations. No questions? Okay. All right.